No. 11.4, geometric probability. So, probability is the likelihood that an event will occur. It's represented by a number between 0 and 1. It can be written as a fraction, a decimal, or a percent. And notation for probability, like the probability of an event A occurring, is written as the P with the parentheses around the A. So that's read as the probability A occurs. The closer to 0, the less likely something is to happen. Just think about it. Like, what are the chances of blank occurring? The smaller that number, the less chance that it's going to be. The closer to 1, the better the chance is going to be. So if we think about it in terms of percent, 1 is like 100%. 0 is 0%. Okay? Midway between would be a half, or 50-50, 50%. Okay? Those are kind of like your odds. So if you're looking for something to happen, then you want it to be closer to 1, 100% being obviously the odds that it was going to happen 100% of the time. And then closer to 0 would be something you don't want to occur. Okay, like chance of rain, that kind of stuff you would want on the low end. A geometric probability is the ratio that involves geometric measures such as length or area. So this initial section is grouped in, if you remember, with the areas that we talked about. So like areas of triangles and rectangles and polygons and all that stuff. So these will all involve a shape, whether it be a line or a polygon. It will be involved in geometric probability, where the rest of the chapter won't be. Probability and length. So if AB is a segment that contains another segment, like part of it would be CD, and if a point K on AB is chosen at random, the probability that it's on CD is the ratio of the length of CD to the length of the whole segment AB. So if I had literally like left this on the board and I asked you to come up to the board, somebody to come up to the board and pick a point on AB, and we were trying to figure out what's the probability that that point that they pick is going to be on CD, right? Anywhere along here that would fall between C and D. Then I would take the length of CD, which you'll be able to figure it out. There'll be a numeric value. The length of CD and put it over the whole length, okay? So that's dealing with length. If I said the same thing, but I said what's the probability that you would pick a point on AC, how does that change your ratio?
It would be AB minus CD.
Well, I just need, yeah, okay, so what's the probability that would be on AC? So the way you're wording it would be the probability it's not on AC. Does that make sense?
Yeah.
She said take AC away from AB. But if I wanted to figure out what's the probability that you'll land on AC, then I put what you're aiming for, which is AC now, over the length of the whole thing. So it's kind of like, what are you aiming for, and what's the whole shape? Because in this case, it's going to be lines, but eventually, segments, but it's going to eventually change.
So
Yep. Correct. So if I said, what's the probability that a point's going to land on DB, then I would put DB over AB. Does that make sense? Yes? What's the probability that a point would lie on AB? 1 or 100%. Does that make sense? Yeah? Okay. All right, let J be a region, so now we're talking about area, that contains another region, so you've got some sort of shape falling within another shape. If a point K, so K is your random point that's picked, what's the probability that that point is going to be in area M? So again, I'm aiming for M. I take what I'm aiming for, whatever the area of that shape is, and I put it over the area of the whole shape, which in this case is J. The difference is when we get to these will be shapes that you can find the areas of. So these are kind of like obscure shapes that they're giving you. But if it was a square inside a rectangle or a circle inside of a rhombus, you should be able to figure it out, okay? So you put the area of what you're aiming for over the area of the whole shape. Questions so far? All right, so here's an example with an actual segment, no measurement, but a way to figure it out. So suppose a point P on segment AF is picked at random. What's the probability that P is on segment CF And it doesn't give you any measurement, but what it does give you is this information, which is obviously pretty important. If they are all equal to each other, so this equals this, equals this, equals this, equals this. So if I'm looking for CF, how many little segments is that? 3 out of how many whole entire segments are there? 5. So you could have given it value. I could have said each one of those segments is 1 or each one of those segments is 2. And then I could have put counted them up. Or if it's a case like this, you can literally just say each value is 1. If I'd given them any other value, it would have reduced to be 3 to 5. So I can write it like this. 3 to 5 is also 0.6, and it's also 60%. So all 3 of those would work. Yep.
On the quiz, does it matter what you put?
I haven't done your quiz yet. I would imagine I'll be more specific, like give it in percentage or fraction or ratio. Okay, example 2. At a carnival game, dishes are positioned on a table so that they do not overlap. You win a prize if you throw a nickel that lands on a dish. If the area of the table is 1.5 meters squared and the combined area of the dishes is 1 meter squared, what's the probability that the nickel will not land on the dish? So give yourself a visual, right? Like if I've got a table, and then I've got a bunch of dishes, and I don't know how many, but they say that they're on there and they don't overlap. These are not very good dishes, but let's just pretend, okay? And the goal is to land in those, so dish, 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 dish. Not the goal, but that's what you're aiming for is to throw a nickel onto that, okay? So if I was to ask you what's the probability that you'll land on a dish, I would take the area of all the dishes, right? And put it over the area of the whole thing. What would that have been? What's the area of the dishes? 1. What's the area of the whole thing? 1.5. Okay? That would be if that's what I was aiming for. But what's the question asking? That it won't happen. So what's the area in which it wouldn't be a dish? 0.5. If I take that total area and subtract from it the 1, it would be 0.5 over 1.5. But we cannot leave decimals in fractions. How do I get rid of them? You could do a half over 3 halves, keep, change, flip. That's one way to do it. What's another way to do it? How can I move a decimal? Multiply everything by 10. So multiplying by 10 moves it one place. Yes, you with me? So I can say multiply this whole thing by 10, and I'd get 5 over 15, which reduces to 1/3. You would have gotten the same thing, so Arel has said maybe change it to 1/2, right? That would be 1/2 over 3 halves, keep, change, flip. I still would have gotten the same thing, 1/3. Yes?
Why did you get 0.5?
Because it's the area in which the plate is not, right? So the whole area is 1.5. The area of the dishes is 1. If I take that 1 meter squared and subtract it from the 1.5, I have all that red area in the background. That's what it's asking. So this type of question, I would prefer it left as a fraction, because what happens if I convert that to a decimal? It's repeated. I'm going to have to round it. It's no longer 100% accurate. Does that make sense? So if you have to round it, don't do it. Leave it as the ratio. Okay? So instead of making that 0.333 or 33.3%, I would rather you leave it as the 1/3. Questions on that one? All right, this one says a dart lands at a random point on the square dartboard shown. What's the probability that the dart is within the outer circle and then within the bullseye? And I'm actually going to take this off. We're going to leave it in terms of pi. So it's 2 separate questions. What's the probability that the dart is within the outer circle? And then what's the probability that it's within the die? So first, outer circle. I need the area of the outer circle. Over the area of the whole thing. What shape is the whole thing? Good. You with me so far? Okay, how would I find, let's start with the easy one. How do I find the area of the square? It's 10 times 10 or 100. How would I find the area of the outer circle? So we're talking just that ring that kind of looks like a donut. 16 pi is going to be the whole circle, right? Minus the 1, right? So I'm going to take from the whole circle and subtract that innermost part. Does that make sense? So I'm going to do the area of the whole circle minus the area of the little yellow circle. So the area of the whole circle, it gives you that the from here to here is 4 and from here to here is 1. What's the radius on that circle? 5. So this is 25 pi because it's pi r squared. Minus this little circle in here, the radius was what? 1. So 1 squared times pi would just be pi over 100. And I get 24 pi over 100, which I can reduce, right? This would be 12 pi over 50, or 6 pi over 25. So that would be the probability that it's within the outer circle. Which I think is harder than the next question. What's the probability it lands in the bullseye? So what's the bullseye? That little yellow circle, which is the 1 pi. So I would say just pi over the whole area, which is 100. So you can leave it like that. If it had said 3.14, I would have written 3.14 over 100, and I have to move the decimal twice and reduce it. But we're going to just leave it in terms of pi. Questions? Okay, so general concept, like it's shape within shape. You've got to find the area of what you're searching for and put it over the area of the whole thing. Not bad, right?